This example, we got a couple of u's here, and it's asking us three questions about it. Where's the limit defined? Where's the function continuous? And where's the function differentiable? Well, first off, what does it mean for a function to be defined? It means that if you have a graph, say that it kind of comes up like this, and then continues off this way. And maybe it's a solid dot here and an open dot there. So right at that point, it's not, I'm using the wrong word here. The limit does not exist. That's what I was getting my terms confused. So the limit does not exist. Why? Because for a limit to be defined, it's got to be the same from the left and the right. It's got to be the same from the left and the right. Another way it can go bad. Let's do this. Let me add to this. What if it goes up, up, up? Let me just try like this. Up, up, up. Well, let's try this. If it goes up, up, up like that, and then down, down, down like that, and then whatever, off it goes. So then right at this point, again, the limit does not exist. It's not defined. Because why? Because it's going up to positive infinity on one side and down to negative on the other. Now you think, okay, what about here? It's going up and it's going up. Yeah, that's okay. They're both going up to positive infinity, aren't they? So at one, it's okay. Both sides are going up, up, up to the same. They're going the same direction. It's okay to go to infinity as long as you both go to the same infinity. You can't have one going down to negative infinity and one going up to positive infinity. That wouldn't exist. So basically everywhere from 0 to 2, everywhere from 0 to 2, this function, the limit is defined. It never has the, you know, left and right doing different things like that. Okay, then what about the next question? Where is it continuous? Now, to be continuous means you don't pick up your pen, just continue. So if I draw right there, I got to pick up my pen, don't I? So right at one, I had to pick up my pen. It's not continuous right at one. That's what they said in this interval. Now, I don't know how familiar you are with interval notation, but you might say, Mr. Aaron, why don't they just say 0 to 2? That's just basically everything from 0 to 2. They just said it in two different pieces. Yeah, sorta. They did say it is everything from 0 to 2, but it's not including the 1. Not including the 1. How do I know that? Well, you got to be familiar with interval notation. Do you remember like if I write 0 to 2 like that. That does not, it does not include 0 or 2. Whereas if I write like bracket, let's go to 0 and 2, 0 and 2 with the, say, a parenthesis, you can do both brackets, both parentheses, mix and match, whatever. This then includes 0, but not the 2. So do you remember that? So brackets have a straight edge to them. So if it's a straight edge, it's straight on the 0. We include 0 straight on. But the 2 has a parenthesis, which means you're around the 2. Think about that. It's rounded. You're around the 2, but you're not right on 2. You would include everything from 0 to 2 all the way up close to 2, like 1.9999999, but not straight on 2.0. You're round the 2, not right on the 2. So you can have both brackets, both parentheses, one bracket, one parenthesis, whatever. So when they specifically here put a parenthesis, not a bracket. They could have put a bracket and that would have included the one, but they didn't. They put a parenthesis and then they put a parenthesis there as well. So that's why they're not including the one. So yeah, they're saying everything from 0 to 2, but they're not including the one. They're saying 1, you're out. And that's right, because at 1, the function does not continue. It's not continuous. Last question. Where is the function um, differentiable? What does differentiable mean? It means smooth, not not jagged. Smooth, not jagged. What do I mean? Let me draw a little example of a graph again. Say you got a graph and you got a function. It kind of comes up like that and goes down like that. That would be a jagged point. It's not smooth there. So differentiable means smooth. We don't like that in math and science. We like smoothness. This is kind of increasing levels of niceness. So we'd rather it kind of round it out there, you know? We don't like that. It's going this way. Oh, whoop, jagged, move the other way. That's not smooth. We call that not differentiable. We're using that word because that's what chapter three, it's a preview of coming attractions. Chapter three, our next chapter is all about. It's about derivatives. And so they're giving us a look at graphs now. How do we look at a graph and know where a function is not differentiable, not smooth? Well, back to it. You can see right here at 0.5, see that little jag? It's not smooth right there. And at 1.5, it's not smooth. And certainly at 1, it's not smooth because it's not even connected, right? Say at 1, the left side and the right side don't even connect. So it can't be smooth if you're not even connected, right? So this is like increasing levels of niceness. We like the limit to be the same from the left and the right. We don't want missing left and right. We got that. It's the same. Even in the middle, it's the same left and right. Then we say, okay, yeah, but even higher level, where's it continuous? Where's it continue? Well, it continues not in the middle there. You have to pick up your pen. Okay, then even a higher level, we like it not only to continue, same left and right continue, but even be smooth. Well, it's not smooth at 0.5, 1, and 1.5 everywhere else. So here's their answer. See how their answer here does not include those points? It's basically everything from 0 to 2. But see how 0.5 and 1 and 1.5 are not included, right? Because see, they put the parentheses on the 0.5, parentheses on the 1. So 1 and 0.5 and 1 and 1.5 are actually not included. It goes everywhere from 0 to 2, 0 to 2, but not including 0.5, 1, and 1.5. Everything else is in because it's not smooth at those points. It's jagged or not even connected at those points. Everywhere else, it's smooth. It's differentiable is the word we use. And so there we go.